listen.
Hi everyone, we're now going to do our second bit of PGFs, probability generating functions, and we're going to look at those of standard distributions. Now, we will have PGFs for all of our regular discrete distributions that we've learnt so far, so binomial, Poisson, geometric and negative binomial. All of these are given in the formula book, but you should also be able to derive them. And, hopefully you'll be asked to derive them, because if you aren't asked to derive them, that should be a pretty easy 5-mark, 7-mark, etc. question, because it follows the same process every time. Okay, so we're going to start off, we're going to do example of all 4 of them. Okay, so we'll go in order as you'd expect, and we're going to start off with this one, example number 1. So here we go, an archer hits the bullseye with a probability of 0.6. She fires 3 shots at the target, and the random variable x represents the number of times she hits the bullseye. Find the probability generating function of x. So, hopefully, with our stats brains, we can see that we've got a probability of success, and our probability of success is 0.6. We've got a set number of trials. You either hit them or you don't. So this is going to be a binomial distribution with the number of trials 3 and the probability of success 0.6. Okay, that means we can then work out our probability mass function. Okay, now obviously if I am trying to hit a target and I'm doing it with 3 trials, that means I can either hit it 0 times, 1 time, twice, or 3 times. Those are the only outcomes. Okay, now in order to work these out, obviously you could just bung them into your calculator. However, we are going to use the formula for the binomial distribution. And the reason we are going to use that is because, here it is, because that will help us with our PGF. Okay, so this is the formula we're going to use. Now, I hope you can see it, but it is in the formula book, it's on page 8. You have been given that when you have a binomial, the probability that x equals x is given by n choose x, p to the x, 1 minus p, n to the minus x. Okay, hopefully that is using the NCR button and is that notation there. Okay, so if you do that, what you end up having is 0.4 to the power of 3, and that is because obviously our x is 0, so that will just be 1. I haven't got my calculator with me, but n choose that is just going to be 1. Okay, n choose 0 is just going to be 1, n being 3. So 3 choose 1 is just going to be 3 choose 0 is going to be 1. And then 1 minus p, so 1 minus 0.6 is 0.4, and that's to the power of 3, take away our x, which is 0, so that's just 3. Okay, I'm using a similar method. This is going to be, oh, I didn't leave myself enough room. 3, that's from this, 0.4 to the power of 2, oh, is this bit, and 0.6 to the power of 1. This bit here is going to be 3 lots of, let's try and fit it in this time, 0.4, and then 0.6 to the power of 2. And then this last bit is going to be 0.6 to the power of 3. Okay, now we then know that probability generating functions is the probability mass function times t to the power of x. Okay, now I'm going to leave these with powers, and you'll see why at the end. Okay, I'm just going to leave these, rather than work them out as numbers, I'm going to leave them as they are. So here I've got 0.4 cubed t to the power of 0 plus 3 lots of 0.4 squared times 0.6 t to the power of 1 plus 3 lots of 0.4, 0.6 squared t to the power of 2, and finally 0.6 cubed t cubed. Okay, now let's tidy that if you like. That's obviously just 0.4 cubed. That can stay as it is, but obviously that's just a t. And here we go. I've used a lot of brackets here, but hopefully you can still see what is going on. Okay? Right, now here's a jump. here's a jump, but I think once you see it, you'll be quite satisfied by it. Okay? Right, now, what I should have said at the beginning of this video is I should have sort of pointed you into the direction that we were aiming for. Okay? Now, these PGFs, the general PGFs, are given to you on page, I will tell you when I find it, on page 23, okay? So page 23 of your formula book, you have been given your PGFs, and they're in the form of this table, and just at the end here is all the PGFs, okay? And the binomial one is in a specific form, and so that's the form I'm going to try and work with, okay? So that's page 23. So once we've got this into this form, the reason I've kept it like this is because then when we get to this point, we can then hopefully really nicely sort of factorise this, okay? And the reason we can factorise this so nicely is because we're going to refer to, let me write it down here so that you can see it, I'm going to refer to this, which is on page 5 of the formula book, okay? This is the binomial expansion, and the binomial expansion is written like this. Now, we very rarely use this one, and you probably haven't used it very often, in fact. Anyway, but here is your binomial expansion in this form, and what you will notice is that we've got that to the power of our number of trials, and then as each of these powers decrease, this one increases, okay? So that is literally just what's happening here. Look, I can marry up this formula quite easily by saying, okay, my n is going to be 3, n is going to be 3, my a is going to be 0.4, okay, there's my a, there's my a, and my b is going to be 0.6 t, okay, there's my b, 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 there's my b in b cubed, okay. It might help you if you think about it written like this, where you're shimmying together your coefficients of t. So you're saying that this one is 0.6t, and that's all being squared, okay? Because then you can see that that's 0.6t, and that's all being cubed. So that is your b value, okay? So I'm going backwards from this to try and get it into this form. So my a is 0.4, my b is 0.6t, and my n is 3. So I can factorise this being 0.4 plus 0.6t all cubed. Okay, now that is exactly what we wanted to happen. Oh no, I've just ruined one of my pieces of paper. That is exactly what we wanted to happen. Oh, go away. Don't want that anymore. Can we see that now? There we go. Exactly what we wanted to happen because our standard binomial PGF, let me get a piece of paper. I keep ruining my work. So our standard binomial PGF is that gx of t is 1 minus p plus pt to the power of n. Okay, well, here our p was 0.6, so there's our 0.6t, our n was 3, so that marries up, and our 1 minus p is 1 take away 0.6, which is 0.4. Okay, and so that is the standard way to do it. If you do it like this every time and you don't write out your actual probabilities, that is going to make it much, much easier for you. Okay, I'm going to stop this video and do another one for Poisson, so there's not so many in one go.